A few days ago I posted a video on this machine. It's the FlashForge Guider 2, and I had a bit of a rant about how I thought it was a terrible design. Aesthetically it's quite nice to look at, but there are some fundamental problems with it, and some people reported issues they were having trying to get it to work. And some of these were things I'd seen on this machine, so I thought I'd do this follow-up video just to show how I addressed those issues and managed to get the machine to work. The first thing to bear in mind if you do have one of these and you're struggling to get it to print reliably is that there is a fundamental flaw with the design of the machine, and that is the home sensor for the Z-axis is right at the bottom of the machine. So when a home command is issued to drive all the axes back to their home positions, then as you might expect, the X and Y are fine, they just go to the corner of the machine, but the platform drives all the way to the bottom, and it uses that as the origin for the Z-axis when it wants to print. The problem there is when it drives all the way back up to the top, bear in mind this has got a 300mm Z print area, that means that there's a big difference between the position of the home sensor and the start point for printing. That means that as the machine warms up, mostly due to changes in length of the lead screw, then the start position for the platform is very unpredictable, and quite often you'll see in the forums that people are reporting various problems getting the print to stick to the bed, or it's inconsistent, it's not level. And what you can find is, even if you level the bed very carefully just prior to a print, but the print covers quite a big area, then as the machine warms up, by the time it gets from the start of the print to the end of the print, the platform height, even uncommanded, can change by several layer levels in height just due to this lead screw expanding. And one of the ridiculous things is there is a sensor in the head, there's a position sensor in the head, but they don't use it to zero the Z position. So if you are having problems getting a consistent start to the print, more likely it's not because you're making a mistake, it's because the machine itself is just changing shape as it warms up. What I tend to do is, at the beginning of the day, is I'll keep the top on, so I'll have the cover on, I'll close the door, preheat the bed to 60 or 70 degrees and leave it for an hour before I come back and start printing. That at least stabilises the machine to a certain degree, and it will eliminate a lot of the problems in trying to get this thing to act in a consistent manner. In the previous video I showed how I levelled the bed using paper shims, so I won't go over that again. One of the main issues that seemed to come up was that this thing will stop printing halfway through long jobs, and this is something I had quite a lot when I first got it. So you'll start to print off, it'll run for maybe 2-3 hours, and then it keeps going through the motions of printing, but it stops extruding, and it doesn't start extruding again. You'll come back and this thing's still going away quite happily, but the print head, the nozzle, is now maybe an inch above the last position it actually extruded onto, so the model you're trying to print is incomplete, and it can be fairly inconsistent, but generally it's quite a long way into the print. Now, this took me a while to figure out, and I had it coming up now and again. It's worse with PLA, so it did seem like it was temperature related. Different types of PLA showed the effect to lesser or greater degrees, but what it turned out to be is the motor, the extruder motor, is overheating, and I will be shortly modifying this machine to do a proper fix for that, and I'll post a video once I've done that. And what happens, because the head's enclosed, although there are fans on it, the fans are blowing hot air across the motor rather than cool air. And as the motor heats up, because there is no thermal barrier between the stepper motor in here and the drive gear that's pushing the filament into the extruder nozzle, there is about an 8mm gap between the point on that gear where it's pressing on the PLA and trying to push it into the nozzle, and the start of the nozzle itself. And because that gear is directly attached to the motor, the gear gets very hot, and it gets hot enough to warm the PLA to the extent where the PLA becomes fairly pliable, and then rather than pushing the PLA properly into the nozzle, it starts to fold over just above the entrance to the nozzle. And then once it does that, it will just clog up and it will stop extruding. And because the motor is trying to still push filament through the nozzle, it's stalled, it will just get hotter and hotter and it won't restart again. And sometimes you'll find that if you stop the print and restart it, it'll recover. Other times you might have a job jamming it. The only way around that I've found at the moment is to just leave the top cover off and the door open, which in theory you should do with PLA anyway, but it's not ideal, and it will do the same thing with ABS if it's a very long print. You get 5 hours into a print and it will just suddenly stop extruding. The printer won't know it's not extruding and it will carry on to the end of the print, but you'll come back and your print's only half the height it should be. I tend to fit a heatsink to this particular machine. As I said, I'll post a video when I do that, but in the meantime, if you do have that problem, then just make sure it's not in too hot an environment and that you do have the top cover off. Okay, another problem I had with this machine that has been reported by many other people is its tendency to ooze filaments, and you get a lot of stringing across the model. Even if you increase the retraction up to 3 or 4 millimeters, it still does it. The reason seems to be that in this particular print head, it's a very tall head internally, and the PTFE tube that sits in this when you first get it is quite a loose fit in the heatsink that it goes through into the print head. And because it's quite loose and quite long, it means that when it heats up, it acts like a kind of bellows, and when filament is forced into it, it expands. And then when filament stops being forced into it, in other words, when the head wants to stop extruding, even if you retract the filament, that PTFE tube continues to recover to its normal shape, and it causes filament to be extruded, and it oozes out and makes a real mess on the model. I upgraded this head to an all-metal head, and that completely eliminated the stringing. I only needed 0.4 millimeters retraction, and now I get almost no stringing at all. Once you get these things sorted out, then it does improve the machine quite a bit. It's still inconsistent with regard to temperature, so as I say, it needs preheating before it's used. I'm hoping that the manufacturers are going to do something about this, because it does make the machine pretty much unusable, and I don't really see why anyone buying these machines should have to be the ones to sort out manufacturing or design issues. I'm all for companies making lower cost machines available, but when they are fundamentally not fit for the purpose they're being sold for, that needs to be addressed by the developers and the manufacturers, and not people buying them. Okay, there are other issues with this machine. If there's any in particular that you come across that you want me to have a look at, I'll be glad to do that. Just drop a comment. In the previous video I also showed this machine, which is one of the original machines. This has been extremely reliable. It's got a much more sensible design layout, the Z home sensors at the top, so it's very close to the start point of the print. This is a dual head nozzle, dual head model. Again, I've upgraded these to all metal extruders simply because they do seem to work better once you've got them configured. However, one of the issues I did have with this was the print bed itself, and in general I use a glass plate on this. I have used a stick-on textured surface and they do work quite well, but because I want to use glass, and I do tend to print small items on this, I was having a problem now and again with the filament sticking to the glass. Now, as I'm sure you know if you've been experimenting with these, when you stick to the smooth surface of the glass, if you are too close to the glass when you start printing, the filament is dragged across the surface of the glass and it doesn't adhere. With glass generally it's just kind of a suction rather than stiction that holds it in place. You'll notice that when you come to remove models from the surface of a smooth glass plate, and that if you lift it up and put it back down again, it will seem to immediately stick back to the plate, and that's just because there's no air between the model and the plate, and atmospheric pressure actually holds it in place. Now of course that doesn't work when you first start printing because there's no area to hold the model in place. You can use glues and whatever else to overcome that. I never use anything on the surface. I always print on a clean surface. I always clean it with isopropyl alcohol before I start to print. But for very small models I was having a problem on the glass, so what I've done is, this is a standard glass plate and I've bead blasted one side of it. So I used fine to medium glass blast media. It gives it a very nice, very fine textured finish. You can probably possibly hear that. It's very similar texture to what you'll get on the commercially available stick-on surfaces, and it gives extremely good adhesion, and it also means you can lower the first layer to really squeeze the first layer into the plate and it won't drag along because of the textured surface. But it is a very fine finish, so it still gives you a very nice finish on the underside of the model. The other side I left smooth, so if I want a smooth surface to print onto, just normal glass, I turn it over, and if I want to have a very good adhesion, or if I'm having problems getting it to stick to the glass, the smooth glass side, I flip it over, clip this on, and that solves the problem. So that does make life a lot easier. If you do try this, obviously be careful that you don't have your bead blast pressure turned too high, you could shatter the plate. Okay, so hopefully that was of some help to anyone having the same problems that I did. If there are any other questions, or if you've been having problems with these, then please drop me a comment. If I've seen the same thing and or found a solution, then I'll post another video.